Okay, so we're going to start Unit 6. First thing is geometric mean. So you're going to see how this relates a little bit. You don't have to do it. There are a couple different ways to do this. So first thing we're going to talk about is extremes of a proportion, because every proportion has two parts. It has extremes and means. So when I talk about extremes of a proportion, it is going to be the highest. Ooh, turn this on. Okay. The highest and lowest numbers in a proportion. So for example here, if I had, well, I know 1 over 2 is equal to 3 over 6. These two right here, these are called my extremes, because they're my highest and lowest number. The other part of the proportion is the mean, which is the middle numbers. Okay, so same example, in 1 over 2 is equal to 3 over 6 in this proportion. 2 and 3 are called means, because they are between 1 and 6. They're between your extremes. We're going to talk about a little bit today is geometric mean. Geometric mean are when the means are the same in a proportion. That's the geometric mean. So if I was talking about a geometric mean proportion, I would say 1 over 2 is equal to 2 over 4. Okay, and you see our middle numbers, 2 times 2 is equal to 1 times 4. Our middle numbers, that's a geometric mean because it's the same. So you guys can use a shortcut. I set up the proportion each time. And so I'm going to do, for this one, this is the geometric mean of 2 and 8. So these are, what I'm giving you is the extremes. You have to find the identical mean. So that would be 2 over x equals x over 8. So I cross multiply, and I have x squared is equal to 2 times 8. X squared is equal to 16. And I take the square root of each side. X is equal to 4. And we're only going to do the positive for geometric mean here. My next one, I just do 6 over x equals x over 24. So I cross multiply, x times x, of course, so this would be x times x equals 6 times 24. X squared equals 6 times 24. X squared is equal to 144. I take the square root, take only the positive root, x is equal to 12. And then my very last one, 5 over x is equal to x over 15. So x squared is equal to 5 times 15. X squared is equal to 75. Okay, x is equal to radical 75, but you want all of your answers in simplest radical form. So you have a couple things you can do. 75. You can do this. 75 divided by 2 doesn't divide by 3 is 25 is 5 times 5, which is 5 times 1. Okay, and so there's going to be a 5 on the outside, radical 3, and that's our answer there. Okay. Geometric mean also appears in other places. It appears in geometry. You may or may not see this with these, but so we're going to talk about, this is called my altitude to hypotenuse relationship. This right here is the altitude. This right here is, of course, my hypotenuse. And this is when you draw an altitude to hypotenuse of a right triangle. We're going to talk about the triangles that are formed. And this actually is pretty important later on. So first thing it asks, or I ask you, is to draw the triangles ADB and ABC separately. Because what I want you to realize is, well, I'll draw it ADB. So ADB, that's this little triangle here. So A, D is where my right angle is, and then B, A had a little circle in it. And my other triangle is ABC. I like to draw them so they're the same, even if it doesn't even look like a triangle sometimes. And this would be A. And so do you see that the angles that are congruent, I put them in the same position? B, and C has a little X next to it. All right, so that's the first thing I'm going to do. Things that you might notice if I highlight all of the parts. AB here, I have an AB here, and I have an AB here. So the AB on the small triangle is the hypotenuse, the AB on the bigger triangle is a leg. If I were to highlight the rest of this, let's go with a orange. Let's do BD, BD. They don't share that one. Let's see. AD, AD. And then BC, BC, and D, or then AC is the whole thing. AC is the whole thing here. So one thing, and I'm going to go through this quickly again, is you notice that the hypotenuse of one is the leg of the other. Now, the first thing that you're asked is ADB similar to ABC. Well, I know this angle is congruent to this angle, and of course they both have this right angle, so I would say yes by angle, angle. If I know that they're similar, if I know that ADB is similar to ABC, then I know side AD over AB is equal to BD. I always write in alphabetical order over BC, which is equal to AB over AC. Okay, it's our statement of proportionality from our last unit. Okay. And it says choose the two ratios that involve the same side and cross multiply out. Okay, so what you notice is the thing that I kind of made a note of earlier, is that this one has AB and this one has AB. So I'm actually going to throw out that part because these two have a relationship to each other. And this is actually kind of special because usually to solve a proportion you'd have to have 4 parts, but with these proportions you only need 3 parts because 2 of the parts are the same. So I know AD over AB is equal to AB over AC. I cross multiply. I have AB squared is equal to AD times AC. And that's going to be true for any right triangle where you draw the altitude to the hypotenuse. So it's AB squared. So I'm going to say leg squared, whenever we talk about leg and hypotenuse, it's always the biggest triangle, is equal to AD. Well, that's going to be part of my hypotenuse times AC, which is my whole hypotenuse. So this is the way I like to do this. I'm going to say, all right, for any right triangle that's drawn, I know leg squared is equal to part of my hypotenuse times my whole hypotenuse. Now, how does this relate to geometric mean? Well, right here is how it relates. The leg of your right triangle is the geometric mean of a leg of the small and hypotenuse of a large. Now you can also think about it this way. So AD over AB, that's so leg over leg is equal to hypotenuse over hypotenuse. Okay. Next relationship. So there are three triangles here. It's like Goldilocks and the Three Bears. So we were comparing the biggest triangle and the smallest triangle. Now we're going to be comparing the biggest triangle and the medium triangle, which is this one right here. I don't know if I need my sparkly pen for that. So it says draw BDC. Well, BDC is easy to draw because it's oriented correctly. So this is BDC. Okay, and then I'm going to draw another triangle oriented the same way, and this is going to be A, B, C. I noticed that there's a little X on this one. On my biggest triangle, there's a little X here. So are they similar? I'm going to say yes by angle, angle. Because these angles are congruent and they both have the right angles. I know BD over AB is equal to CD over BC, which is equal to BC over AC. And we do the same thing that we did with the previous problem, is we look for the two ratios that involve the same side and cross multiply. In this case, I notice here that I have a BC here and a BC here, so that's the one I'm going to recognize. So I have BC, BC. Now I'm going to actually go through and kind of highlight the sides, the other two sides. So we have CD, and my other side, just in another color, is AC. So if you guys look at this, this is just a simple proportion. It is hypotenuse over leg equals hypotenuse over leg. So if you don't memorize these ideas, you can just kind of look at that relation of that hypotenuse over leg, hypotenuse over leg. So this is CD, BC, BC, and AC. So when I cross multiply, I have BC squared is equal to CD times AC. And so when I look at this, it's BC squared, which is a leg of my right triangle, is equal to CD, which is actually part of my hypotenuse, times AC, which is my whole hypotenuse. So what I see again is I have BC's leg, so if I square the leg, that's going to be equal to part of the hypotenuse times the adjacent part. The adjacent part times the whole, excuse me. So leg squared equals part times whole. All right, one last relationship. We have not compared the littlest triangle to the medium triangle. So this is A, D, B. And this is going to be B, D, C. I know they both have a right angle, and they are both similar to each other, basically because we know that this angle was congruent to this angle on the largest triangle, so since it was also congruent to the one on the medium triangle, so they all had to be congruent. So this is going to be yes by angle, angle. Okay, my ratio, it's going to be AD over BD is equal to BD over CD, which is equal to AB over BC. I look for that relationship. I'm going to cross this one off. I notice that I have BD here and BD here. Here's my BD, here's my BD. I highlight the other parts, so I have AD and AD. So I know that that other relationship is CD and CD. So it's going to be leg over leg, short leg over long leg equals short leg over long leg. And that's another way of looking at it. So the proportion I'm going to be honing in on here is going to be AD over BD equals BD over CD. And so when you cross multiply, that's going to be BD squared is equal to AD times CD. And so I have a different way of doing this, but again, you guys can think about it as short leg, like in this case I say short leg over long leg equals short leg over long leg. If you want to look at the similar triangles, this is my little shortcut. BD, so it says BD squared. Well, that is my altitude. So it's going to be altitude squared is equal to AD, part of my hypotenuse, times CD, which is my other part. So you're multiplying both parts. So whenever we talk about part, it's always that part of the hypotenuse. So it's going to be altitude squared is equal to part times part. We're not going to write part squared because those are two different parts. So summarize geometric means. First geometric mean is, you can think about it as short leg. So you can do, that's going to be AD over AB. Short leg over long leg is equal to AB over AC. Okay, you can think about this as short leg over hypotenuse equals short leg over hypotenuse. That's one way to think about it. Or you can do the little cheat. Okay, that's my AB squared is equal to AD times AC. Or in my case, I always say leg squared is equal to part times whole. Geometric mean 2, we're talking about the other side. So in this case, it was CD over BC is equal to, so CD over BC is equal to BC over AC. And I'm going to say this is going to be a long leg of my triangle over the hypotenuse is equal to long leg of the other triangle over the hypotenuse. That also works. When I cross multiply, I have BC squared is equal to CD times AC. Okay. But it's basically the same relationship. We have my leg here. This squared, because that's the geometric mean, is equal to the part times the whole. So leg squared is equal to part times whole, if you will. Last one, of course, the last relationship for geometric mean is now I'm comparing the two smaller triangles. So it's going to be short leg over long leg. So short leg over long leg is equal to, now BD is the short leg of the medium triangle over the long leg, which was DC. Okay, this is one of the ways to think about it, short leg over long leg equals short leg over long leg, if you're talking about setting up that similarity relationship in that proportion. I do it this way, BD squared is equal to AD times CD or DC. And so my shortcut, of course, is it's going to be altitude squared equals part times part. Okay, so those are the three rules, but actually there's only two that you really have to know. And so when I'm given a problem like this, I think about my different relationships, and I actually set it up. But one of the first things that I always do is I always add or subtract to find the parts of the hypotenuse. Okay, because the hypotenuse is key. So 9 plus 4, I know that this is going to be 13. So I look at my relationships. I know we have leg squared is equal to part times whole. So I know x squared is equal to 4 times 13. I can also use that. I can also do z squared. My leg squared is equal to part of my hypotenuse times my whole hypotenuse. That's lovely because I can already simplify those. And then my last relationship is, of course, my altitude, y squared, is equal to part times part. Okay, or you could do short leg over long leg equals short leg over long leg, and you can do the proportion. You end up with y squared is equal to 4 times 9. So altitude squared is equal to part times part. And all you have to do is go through and simplify. So x is equal to, so I want to get rid of my square root, the square, I take the square root of 4 times 13. Here's just a shorter way of doing it. So x is equal to the square root of 4 is 2. I don't know the square root of 13, and so x is 2 radical 3. Z, I take the square root of each side. Z is equal to, I can take the square root of 9, which is 3 radical 13. That doesn't need to be simplified. And then y squared, I can take the square root of each part. Y is equal to 2 times 3, because it's the square root of 4 times the square root of 9. So y is equal to 6. All right, so set up the 3 relationships and then figure out which one you can solve for first. Okay, this next one, I know the whole side is 10. This side right here is going to be 10 minus x. Okay, so I'm going to set up my 3 relationships. I know leg squared is equal to part, the adjacent part times the whole, because it's hypotenuse over leg equals hypotenuse over leg. So, but 6 squared is equal to x times 10. I can also do that on the other side. Z squared is equal to part, which is 10 minus x, times my whole, which was 10. Not solvable because I have 2 variables. And then my last relationship is y squared is equal to, so my altitude squared is equal to part times part, and so that's going to be x times 10 minus x. Okay, the only one I can solve for is this guy right here because I have 1 variable. That's going to be 36 is equal to 10x, divide by 10, divide by 10. X is going to be equal to 36 tenths or 18 fifths. And you could use decimal for this because it's accurate. I'm just going to use the fraction. So if x is equal to 18 fifths, then I know that this part right here, so this part is 18 fifths. This part right here is going to be 10 minus 18 fifths, which is 50 fifths minus 18 fifths, which is 32, or hold on, 32 fifths, yep, which is going to be quite helpful. So in this case, when I do z squared, well, z squared is equal to this part, this 32 fifths, times the whole, which was 10. So z squared, I don't need these anymore. It's going to be this right here, the 10 minus x was 32 fifths times 10. 5 goes into 10 2 times. So z squared is equal to 32 times 2. Z squared is equal to 64. I take the square root. Z was equal to 8. So there's my second one. Then y squared. So my altitude is equal to part times part. So that was going to be 18 fifths times 32 fifths. Okay. I multiply across. Y squared is equal to, since they're not perfect squares, I am going to multiply them out. It is 576 over 25. I take the square root. You can take the square root of each part. And so y is going to be equal to 24 fifths, and that's your other answer. All right, I have 2 more. If you feel like you have this, you don't need to go to the next 2. So there are ones like this one here, this next one, where you can use Pythagorean theorem if you know it, just as a clue. But if you don't, then we're just going to do it this way. So I know if this is x and this is 12, remember I told you that's the first thing I do is I find my hypotenuse. This is going to be x plus 12. So now I go through and I set up all of my proportion, or all of my relationships. So I know leg squared is equal to adjacent part times whole. So y squared is equal to x times x plus 12. That's not the one I'm going to solve. I have two variables, can't do much with that. All right, I go to the other side. Z squared, my leg squared, is equal to my other part, which is 12, times my whole, which is x plus 12. Also a problem because I do not know what x is. My last relationship, of course, is my 5 squared, my altitude, is equal to part times part, which is equal to 12 times x. It's going to be 25 is equal to 12x, because we can solve this because it only has one variable. Divide by 12. X is equal to 25 twelfths. Okay, so that's my first one. Once I know what x is, well, it's not so bad. I know x is 25 twelfths. So x plus 12 is going to be, or x plus 12, my whole hypotenuse, is going to be 25 twelfths plus 12, okay, which is 25 twelfths plus 144 twelfths, because 12 is 144 twelfths, which is 169 twelfths. And that right there is my hypotenuse. Okay, so now I know my y squared, well, that's equal to my x, which was 25 twelfths times my whole hypotenuse, which is 169 twelfths. And this is not so bad because I know, so I'm going to rewrite this. I'm sorry, I don't want to forget my y squared. I know y squared is equal to 25 times 169. I'm anticipating, because I have this squared here and I have to take the square root, I'm actually not going to multiply those out because both of those are perfect squares over 144. So when I do take my square roots, I can take the square root of each individual part. Y is equal to 5 times 13 over 12. So my y value is going to be 65 over 12. And then we go to z. So z is equal to 12 times my whole hypotenuse, which is 169 over 12. And this one was actually delightful because and this should be z squared. The 12s actually divide out to be 1, so z squared is equal to 169. And I take the square root, and z is equal to 13. So that's how we would do that one. If you need to, I'm going to just do this last example, just because if you feel like you have it, go back to this. If you're not sure, if you see someone similar. These are, I think, a bit more difficult than the ones that are on your actual homework. All right, very last one of these. I do the same thing. I add my parts. This is going to be x plus 3. And so I go through. I know y squared is equal to x times x plus 3. I can't solve it. Okay, so then I go, well, I know 9 squared is equal to 3 times x plus 3. Okay, and last but not least, I know, sorry about that, I know z squared is equal to 3 times x. Okay. So altitude squared is equal to part times part. The only one that's solvable is that guy right there, so we're going to solve that one. So this can be 81 is equal to 3x plus 9. 72 is equal to 3x. So when I divide by 3, that's going to be 24. So x is equal to 24. Ooh. Okay, so now we know x is equal to 24. So once I know that x is equal to 24, then I know that my, sorry, that keeps messing up. I know that my whole hypotenuse is going to be 27. Okay, so for this one, I know, change back to the green, I know y squared is equal to 24, the adjacent part of the hypotenuse, times the whole hypotenuse, which is 24 times 27. Neither of these are perfect squares. So this is going to be y squared equals 648. Okay, 648 you're going to have to simplify. Is 324, you can divide that by 2, is 162, divide that by 2 is 81, divide that by 3 is 27, divide that by 3 is 9, divide that by 3 is 3, and 3 is 1. And so we have a 3, a 3, a 2 on the outside, a 2 on the inside, so that's going to be, so y is equal to, when I take the square root of each side, is going to be 18 radical 2. Okay, and then our last one, this one's going to be a little dicey as well. So we have z squared is equal to 3 times 24, which is 72. Z squared equals 72. I have to take the square root. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. 3 divided by 3 is, is 1. So I know I'm going to have 1, 3, and 1, 2 on the outside. And so I know z is going to be 6 radical 2. So those are those three. Hopefully that was helpful. I don't think that there's difficult. Just go through and either set up the proportions or use the formulas, the 3 different relationships, and then figure